All right, this very first question is not in our books. There are similar ones to it in problem set lesson 1 and 2, but not exactly what I was really looking for. I feel like actually lesson 1 and 2 are a lot harder than what this question is actually asking. So here we go. So first question I want to go over. Again, I want to go over 10 specific questions, and there's 10 questions on the test. All right, so I need y'all's help real quick. Give me four numbers. They can be the same, they can be different, they can have negatives. 2, 4, 6, 3, 4. Awesome sauce. All right, here we go. So the things you need to be able to do is do scalar multiplication and then adding and subtracting matrices. Here's a good example. Let's look at 2a minus 3b. You can do this in multiple ways. You can go ahead and multiply the 2 and multiply the 3 and then subtract the 2. Or you can write it all out. However you want to do it, it doesn't matter to me. I'm going to write it out so you can physically see what is going on to each one of these matrices. We've talked about this many times now. When you are multiplying a 3 and there is a minus or a negative in front of it, you could distribute the negative, but if you do, make sure you change it to a plus sign. I find it to be easier to just distribute just the 3, leave the subtraction alone in the next step. All right. Remember, when multiplying scalars, you're taking the scalar that's outside the matrix, single element inside the matrices. I do this, this simply just becomes 4, 8, 12, 6. It's 3, 3, 3, 3. Move on to the. Awesome. All right. All right. Any questions up to this point? All righty. So then after this, you just simply subtract. So 4 minus 3 is 8 minus 3 is 12 minus 3 is 6 minus 3 is awesome. Good. All right. Other thing you need to be able to do, just like we've been doing in the entire module, is be able to multiply. So let's look at what A times B would be. So this is 2, 4, 6, 3 times 1, 1, 1, 1. How do we multiply matrices? Row, column. We've done this all semester. We should be getting really good at this. So to do row times column, remember you do the multiplication, get the results, and then add up their sum. So 2 times 1 is 2, and then 4 times 1 is, and then 2 plus 4 gives me 6 would be the result that goes here. If you need to do this, 2 plus 4, and then write the next step as 6, do it. It doesn't, there's not an incorrect way. Organize your information so you get the correct answer and make a 100 the first time so you don't have to come see me after school. Row, column, what do I get? 6. Again, that's 2 plus 4, so that gives me 6. Second row times each column, so that would give me 6 plus 3, which is 9. Same concept for the other one, which will give you 9. Now, I'm not saying this is what the test is going to look like. Y'all completely came up with these numbers by themselves, but be able to do a scalar multiplication with addition, subtraction, and be able to multiply. We good with this? All right. Number 2, or the second thing I want to go over, will be in lesson 2. And you are not given this in your thing. So this is going to be the exit ticket, but I don't assign the exit tickets. We just don't got that kind of time. So let me bounce back real quick to that. I don't think that's the one I want. Maybe it is. Let's see. We do not. But it's on the screen now. So in the first three lessons, if you recall, this is when we talked about networks and mapping. So you will have to be able to produce a matrix from a given uh, diagram or a network that you are seeing. So let's kind of work through this. Question one says, create a matrix for major highways connecting to three cities. You can. You're going to need to know this information right here. And then I'm going to from there. You can express, you can write all the words, you can simplify it, however you do your note taking. If you haven't learned this yet as juniors and seniors, when it comes to note taking, never write exactly word for word everything the professor has on the board. Paraphrase it, shorten it, condense it, put what you need. Like, for instance, do I really need to write this entire thing? What's the most important things? Good. Highways and railroads between three states. But really, the highways represent the black lines, and the railways produce the red lines, or something along the line, a solid line, dotted line, things like that. Those are your key things you need to focus on. And then over here, kind of do the same thing. Create a matrix A that represents highways. All right, so let's do that part first. All right. Before I even begin to try to understand what kind of matrix I'm going to build, what size should my matrix be? And how do I know? Huh? A 3x3. And how do I know this? There's three cities. If there was four cities, I'd produce a what? 4x4, and then so on and so on. So yes, this would be a 3x3 matrix because there's three cities. If you recall how we build these, you start here. So we start at city 1, 2, 3 here, and then we finish in the column of the city of 1, 2, 3. Those are not part of the answer, but it definitely helps you organize your answer. So now to recall, again, I am doing highways, and highways are the black lines. How many routes are there from city 1 to city 1 with black lines? 0. So there becomes a 0 right here. There are 0 pathways. The next one is how many pathways from city 1 to city 2? Just one. Pay attention to the arrows. There's 2 black lines, but only one of them has an arrow going towards city 2. How many from 1 to 3? 2 to 1. 2 this time. So again, 2 lines, but there are 2 arrows going that direction. 2 to 2, 0. How would I be able to go to the exact same city? What do I usually see? A little loop-de-loop, right? 2 to 3, 2. 3 to 1, 3. 3 to 2, 3, just 1. And then 3 to 3. All right, before I move on any further, questions on how I just built this matrix. All right, this matrix we first kind of discovered is just how many pathways from one city to the next. For this one, it was highways because that's what it told me to do. Part B says, or matrix B says, now do railroads. Railroads was the red line. So I'm going to build a similar matrix of 3x3 in a similar pattern, but this time only paying attention to the red lines. How many railroad pathways from city 1 to city 1? 0. City 1 to city 2? 0. City 1 to city 3? 2. There's 2 arrows right here. City 2 to city 1? 2. City 2 to city 2? City 2 to city 3? 1. Only paying attention to the red line. There's an arrow here, but the arrow that concludes. 3 to 1? 1. 3 to 2? 3 to 3. All right. Again, any questions? All right. So we've now done that, connecting these two cities. feel like there was more I wanted to add to this, but now I don't remember. Oh, that's what it was. How would I find out? Oh, flip this over. How would I figure out how many total ways there are? Add them. What if I specifically wanted to know? We'll do a problem like this later. What if I specifically wanted to know? Actually, we'll do this next. How many specifically to city 1 to city 2 with connecting stop in the middle? What would I need to do there? I would need to multiply them. Very good. So if I'm just finding the total pathways, all I have to do is figure out what A plus B is, which again, just like in the previous example, to add or subtract, we add or subtract from each corresponding element. So 0 plus 0, 1 plus 0, 2 plus 2, 2 plus 2, 0 plus 0, 2 plus 1, 3 plus 1, 1 plus 1, and then 0 plus 0. All right, so again, if you're asked to find total ways, that's all you do is just do A plus 1, B. But if I specifically say I need you to do the highway first, then the railroad, or the railroad, then the highway, this is when we then have to multiply. All right, and we'll look at that at this next problem. Any questions on how to do this process? All right, let's look at the next one. This next one is going to be lesson 3. So again, this will be lesson 3, problem sets. Where's my problem set? It is 2C. So again, this will be lesson 3, problem set 2C. All right. What page number, just for reference? 28. Oh, I did. I wrote it over here. Hold on. Let me just make sure I finished that other problem. Okay, yeah. Okay. Perfect. All right, and then this one for me is page 58. So make sure I hit all my notes. All right, cool. All right, part C just says Oliver wants to travel from city 2 to city 3 by again taking first a bus from company A and then taking a bus from company B. How many different ways are there? So again, I'm wanting to go on one route and then I'm wanting to go on another. But to be able to find out my total answer, I need to build a total matrix. So again, if I'm first doing company A, then company B, and this is going to represent company A and company B, how should the multiplication look? A, then B. So if I want to go first the bus, then take company, or not bus, sorry, first company A, then take company B, I would do EA times B. When we're talking about geometric effects, that is when we want B to go second if we want it to be first, and then A to be first if we want it to go second. But when we're just talking about pathways, it would just go in the order of what I need to take it. I want to do company A first, then company B. So let's build our matrix. So we'll do 1, 3, 2, 3, 1, 2, 4, 3, 2 times 2, 1, 3, 2, 2. Yes, sir. Yes, sir. 2, 2, 1, 1, 3, 1. And again, it is row by column. So let's see how well we produced. What's my first answer? Good. 1 times 2 is 2. 3 times 2 is 6. So that gives me 8. 2 times 1 is 2. So that gives me 10. Row times the next column. 2, 6, 6, 13. Yep, I agree. The next one. 8. I agree. Then take the next row and repeat the process. 10. I agree. I did not get 8. I got 11. Yeah. 3 plus 2 would be 5, plus 6 would give me 11. So again, that would be 3 times 1, 1 times 2, and then 2 times 3. What would be the next one? 12. I agree. And let's do the last one. So last row times first column. 16. I agree. Next. I agree. Last. See, 12, 15, 16, 17. I agree. All right. Now we produced our matrix. That's great. Now let's answer the question. Oliver wants to travel from city 2 to city 3. What is my answer? And how do I find it? Good. This is my row. This is my column. So the first city would represent row 2, and then the second number would represent the third column. So there is my answer. So my answer would be 12. Any questions on how to do the math or how to pull the information you need to answer the question? All righty. We did this in the last review. So I'm just going to, again, I want to highlight it for you. I don't want to spend time on it and waste our time because you can just look back at the previous lesson or less review. But I want you to, again, what is this stuff? Question number 4. Yes. Again, I'm not going to go over it because we went over it in the last review. You can watch that video to catch those notes again. And we've done it twice now. I don't think I need to do it a third time. But go back, highlight star, lesson 12 opening exercise. It was on the last test. It will be on this test. You need to be able to produce a matrix given a geometric effect and vice versa. Okay. These are all basically all the, I think there was like 12 or 13 or 14 of them. But they're all the different ones. What's a node change if you're multiplying, a node change when you're adding, if you want to zero something out, if you are reflecting across a plane, if you're rotating around an axis, if you're rotating around like y equals x, what switches, things like that. So know all those different techniques. Do I need to review any specific one that you're like, I still don't get that one? All right, so I don't want to waste our time, but on number 4, you're going to have to be able to produce something like this. Now, it's not going to be just basic. It could be a combination. It could be saying, hey, reflect around the x-axis at this degrees and then have a scalar on this axis here. So be able to put those together. All right. So that's number 4. And then so now I want to jump back to lesson 7. And we will be, it's in the notes. So it's the exploratory challenge number 1. I do not remember what page number that would be for y'all. 55. So page 55. We'll go to the exploratory challenge number 1. And we're going to look at part A through C, or all 3 of them. And be able to get the answer. Oh, man, where's my stuff? Oh, there's the Zoom. Okay. Oh, sorry about that. It is lesson 7. Yes. Number 5, lesson 7, exploratory challenge, number 1, A through C, page 55. Okay. Try to write all those notes when you're going back to study or whatever you have them. All right, so on this one, we had to plot the image of a unit under the transformation, and we used Desmos to do that, or GeoGebra. You're not going to do that on the test. But then it said find the volume. All right, that is what's specific here. So I want to look at this guy right here for these 3 sections. All right, if I'm finding the volume, what was the easiest way that I determined that? We didn't really produce the formula. We more produced an idea. Okay, what do you mean by, okay, yeah, so it's the X times the Y times the Z, but if I'm just given the matrix and not the cube itself, how can I pull my information to know what my X, Y, and Z is, huh? Just multiplying the diagonal. Now we got a little bit more specific and we'll review those in this next problem, but if I want to know the volume of this, I would simply just have to do 2 times 2 times 2, and I would get what? Huh? 8, perfect. Questions on that? Right. So you could graph this, determine what the cube is, see that it's a 2 by 2 by 2 after that point, and then find the volume, but we found easier ways. And then again, you only have a class period to get this test done, so it's a lot easier to go, boom, multiply, done. We're good here? That's it. I want to look at B and C just in case there's different type of problems. All right. If I kept that same situation and I just multiplied this right here, I would get 4 times 1 times -2, and that would produce what? -8. Can you have negative volume? No, so we added something else to this pattern. We were like, it was the absolute value of this result. So what would be the answer to this question? Just 8. Okay. You cannot have negative volume. So if you do get a negative number, it's the positive result. Go ahead. Then it stays the same, just like what we just got on the other one. It was 2 times 2 times 2, which was 8. Wasn't negative. We didn't have to stress about it, but you're still taking the absolute value of 8, which is still 8. Absolute value does not give you an opposite sign. Absolute value just tells you distance from 0. Distance is always positive. Now, in this case, this is volume, which is, again, always positive. Any other good questions like that? What would be the answer to part C? 0. Why? When I do this diagonal, I have 4 times 0 times -2, which gives me what? 0. What's that telling me about my image? It's now 2-dimensional. It went from a 3D cube and has smushed to a 2-dimensional image. You saw this on your last test. All right. Any other questions? Awesome. All right. I just want to make sure I highlighted everything.
There's a 0. If there's a 0.
Yeah, it'll be 0. Yeah. No, okay, you asked a great question. If there is numbers in the triangle of zeros on the top and bottom, we would really have to graph this out and see what kind of even image do we have. Most likely won't be a cube. It would be a, man, what do they call those things? It's like shifted. It looks like a parallelogram, but it's a cube. It's a 3D image. Was that a prism? The prism? Some type of prism, which we would then have to need to know the prism formula, calculate the height, base, all those different things. So it'd be a lot more complicated. It's a way to do it for sure, but not way that we just have one. Go ahead.
Sorry, Mr. 16 would be in it with the absolute value. Would that take it down to 4?
Absolute value just makes it positive. Does not change the value of this sign other than making it a positive sign. Yeah. What you're thinking is the square root of 16. All right, any other questions on that part? All right, for the next part or part 6, I want to jump to lesson 9. But this again is on an exit ticket, which you do not have, but it will reference from lesson 9. Let me pull it up on the screen for you. Okay, here we go. Again, this is lesson 9. We on part 6? Yep, part 6. Lesson. Am I going too fast? All right, okay. I would almost write everything here, except for this. You don't need to see. Yes, yes. All right. So here we go. So in this exit ticket, it says, let A be the matrix representing a rotation about the z-axis of 45 degrees. So if you take lesson 12, all those 14 different things that we looked at, use that to be able to perform an actual matrix. So let's do that first. Again, this is a rotation about the z-axis. What's that tell me? Good. The z-axis doesn't move, and that's the third row. And if I know the third row is not moving, I know the third column's also not moving. It's going to stay the same. All right, then it's a 45 degrees. You can do this in one of two ways. I know you're getting to a point where you're starting to see these patterns. You can plug it in with cosine of 45, negative sine of 45, sine of 45, and all that stuff. Or you can go straight to what the coordinate is for cosine sine and plug it straight in. I'm good either way. As your teacher, I will put the cosine stuff so you can understand where these numbers are randomly coming from. But you can go ahead and move on to that step if you see the pattern. So this would be cosine of 45. Remember, we go from top to bottom, left to right. And I'm going to squeeze it in here. I did not give myself enough room. All right. So again, that's cosine, negative sine, sine, cosine. All right. After that, we just pulled information. Now, what's nice about this one is they're all the same exact fraction. So it ends up being the square root of 2 over 2, square root 2 over 2, 0. Square root 2. Oh, sorry, that's a negative. Why is this one a negative? It's part of the formula. So square root of 2 over 2, square root of 2 over 2, 0, 0, 0, 1. Questions? All right. Then it says write a matrix B. This time it says B, the matrix representing a dilation of 2. It does not specify which axis gets a scalar of 2. So what's that tell me about all of my axes? They're all going to get 2. So what's that matrix look like? You should be your own choir. Right? But yes, again, this goes back to that R000, R000R, but this time the dilation of R is 2. Questions on that? Okay, so that was part A, which does just write down part A and B. Part B says let X be this coordinate, 3, -1, 2, or this vector. We're going to find the matrix representing a dilation of X by 2, followed by a rotation about the Z-axis. What needs to be multiplied first this time? Good. I want A to be the first thing since I want that shift to be last. So again, since I am going to be using matrix B first, then matrix A, when it comes to multiplication, I would then need to do A times B. Please don't get that mixed up on the test when talking about buses and highways. If I'm doing buses first, then highways, then I want bus, then H. All right. But if I'm doing geometric effects and I want matrix B, then matrix A, then it's A times B. Okay, so don't get those two confused. Let's see that coming. All right. So railroad, highway, that's R times H. If I want geometric B to happen, then geometric A, then that's A, B. Because I want, okay, we good?
It describes it B and then A in the question. A times.
Exactly. It does the opposite when talking about geometric, but when talking about this railroad highway, that's the order you multiplied in. All right. Yeah, so like for instance, if I say I'm doing a rotation first, then a dilation, now I want B times A because I wanted A to happen first. All right, so what you're going to do first is you're going to figure out what A times B is, take that response, multiply it to your X, that would give you your answer. So let's practice that. Am I running out of time? Okay. We will go fast. All right, so A would be square root 2 over 2, negative square root 2 over 2, 0, square root 2 over 2, square root 2 over 2, 0, 0, 0, 1. Multiply that by 2, 0, 0, 0, 2, 0, 0, 0, 2. You can do the row by column, but in reality, you're really just multiplying this matrix by 2. So this ends up being square root of 2, negative square root of 2, 0, square root of 2, square root of 2, 0, 0, 0, 2. This is the matrix that it performs. I know I just went fast, but I'm now told I have 12 minutes. So then you take this and multiply it to this 3, -1, 2. Just an FYI, you're taking a 3 by 3 times a 3 by 1. Your answer should be a 3 by 1. Okay, so this would be 3 square roots of 2 plus square root of 2. You should get 4 square roots of 2. Think of this as X. If I have 3 X's plus an X, I have how much? 4 X's, right? Same concept. I have 3 X's minus an X this time. What do I have? 2 square roots of 2. And then when I do this, this gives me 0, 0, and then 4. Questions on how to produce that? The first part? Okay, so if you actually... This? Oh, this was in the problem. This one? All right, so let's pretend these are X's. I'm just going to put an X in front of them. 3 times X is 3X. Negative X times -1 is a positive X. And then, of course, 0, 0. So what is 3X plus X? Replace the X back with a square root of 2. Same concept here. 3X minus an X, because now -1 times X is a negative X. 3X minus X gives me 2X. Replace the X with a square root of 2. This one here, they all zero out, and then 2 times 2 is 4. So don't be discouraged because it has a radical. Just plug in an X as a substitution to get yourself more comfortable with it. Or make it a 1. I mean, you could make that 3 times 1 minus a -1, which would be plus 1. So 3 plus 1 is 4. We bring in the square root of 2. You know, the good questions like that. All right, next topic will be in lesson 12. We're going to look at problem sets 3, B, and C. So this is actually the conclusion of the homework that's due tomorrow. Lesson 12, problem set number 3. You're going to see one like this on your test. Not the exact thing. 3, B, and C. On part B and C, you are asked to first multiply A plus B and A plus B by plugging in some matrices and seeing what you get, and then asking yourself, is that the same thing as AA, 2AB, BB? When you first look at it, what's your response? No, why? Ooh, okay. So if you're talking about with multiplication, order matters, right? So if I do AA and I do AB and then I do BA and then I got BB, you're stating that AB does not equal BA. Very good. Keep that in mind when you take the test. That multiplication is not commutative. Order does matter, right? Another thing y'all could have done is plugged in matrices as well to test your theory. Will some work? Yes, right. If I made them all the exact same numbers, if I use that pattern of this diagonal being the same and this diagonal being opposite, that could give me a true statement. But for it to be an exact truth, it has to always work. All right. So any questions on this? Go ahead. It's not commutative. We've proven that about 2 or 3 times now. With matrices, yeah. With regular multiplication is commutative. 2 times 3 is the same thing as 3 times 2. But we've learned with multiplication of matrices, A times B doesn't mean that B times A. Now, we've seen cases where it does, but it doesn't mean that that's going to be a fact. All right? So just kind of keep that in mind. Also, make sure you have your answer down written for your homework as well. Any questions there? I know that was a quick response, but I wanted to kind of get to it. All righty. The next, and this is for number 7. And again, this was lesson 12. What page number? 98. All right, the next one is going to be lesson 11. The issue is that's an exit ticket. So let me give you some time to write it down. For number 8. Yeah, all right. Not necessarily. The graph is actually going to be given to you, and you're going to be asked to find that. So I'm actually going to kind of graph it for you so you can kind of see what happens. So if I graph, it'll graph X for you. So let's say it's going by 2s. Oh, give me a zoom in. I see what y'all talking about. I was like, why I got the little binoculars going? There you go. Is that better? Okay. All right. So you're going to be asked to find this guy, but you're not going to be given this. You're going to be given a graph. So it's going to look more like this. And it'll say X. And then it'll have, I'm going to do the math real quick here. Yes, that's what it's going to look like on your test if you wanted a good example. All right, so you're not going to be given any of these matrices. What you're going to be given is this graph right here, and you're going to be asked to find A plus B of X. So if I'm only given this, what could I do to figure out this? Thoughts? Again, you're not given any of this. You're just given the graph. How could I find this? You could graph it and figure out where they're going to go. But remember, this guy here is the same thing as AX plus BX. So if I just go figure out what these coordinates are, then I could add them up. So this coordinate right here is -3, 1. And this coordinate here is 4, 6. If I wanted to know what AX plus BX is, I would literally just go 4, 6 plus -3, 1. And what do I get? 1, 7. So again, you will not be given a matrix, so you won't be able to do the math. You'll be given a graph. So what you need to do is figure out what AX is, BX is, and then you would add those up to figure out what AX plus BX is. Questions? Yes. Let's do number 9. We'll do number 9. So that was for number 8. The reference here is lesson 11. Can I erase? All right, this next one I made up. So let's do that. All right, so on this one here, number 9, let's say A equals 1, 3, 2, 5. Let's say I is the identity matrix. What's the identity matrix? Let's say Z is the zero matrix. What is the zero matrix? I want you to find this guy. I told you there was a problem on there that basically brings like everything into one problem. Yeah. I need 2 random numbers.
1, 2.
Awesome. Way to keep it small. All right. What is this? Yes. What is that? Inverse. Very good. A inverse. How do I find the inverse of a 2 by 2 matrix? I do, is it, oh gosh, is it B times D minus A times C? Yes, okay. BD minus AC, right? That's the determinant. We switch the places of A and D and change the sign of B and C. Again, we've determined it does not matter how you label B and C, we'll still get to the same conclusion. So D, oh wait, it's DA. Well, let me fix this. DA or AD minus BC. This diagonal minus this diagonal. All right, so now to do this, let's plug it in. So that's going to be, again, it doesn't matter how you label it. It'll all work out. If you want to do this as B and C, it doesn't matter. AD minus BC. Yes, sir. All right, so that's going to be 5 minus 6, 5, 1, -3, -2. So this becomes a -1, right? 5 minus 6. Okay. So that's 1 over -1, which is just -1, correct? Okay. Take that -1, distribute it back into this matrix. And you would get -5, 3, 2, -1. Questions on how to find the inverse? Here's the formula. 1 over AD minus BC. Switch A and D, change the sign of B and C, work your work. All right. After that, we can find this. A times I. Do I really need to do that multiplication? What's I mean? The identity, which is multiplying by itself. So I'm just going to have, go ahead. All right. We got one more problem. So this would be 1, 3, 2, 5. This would be what AI is. plus 0. Do I even need to add the 0? No, because it's not going to change. So basically, I'm just going to take this -5, 3, 2, -1 times that matrix of 1, 2. So I would do this work first. Notice it's about to go super fast, but this would be -5 plus 6, which is 1, 2, -2, which is 0. Well, that's a nice, pretty number. And then I can do this multiplication. So that would be 1, 2. There's your answer. Do the multiplication of matrices. So row, column, get your stuff. That's what I did here in a fast manner. A times A, sorry. Yeah. This is technically what AI plus 0 is. Last question, and this is for a lot of y'all that were absent. So yeah, make sure you watch the video. But it's lesson 13. That is the decoding. Look at problem sets. So lesson 13, problem set number 6. All right. I don't remember what page that is, but on there, you're given a code of 2, 2, -1, -1, 3. And you are asked to break this code 4, 28, 42, 56, 2, -6, -1, and 52. Do you remember what you have to do first? I need to figure out what the inverse matrix is. So you would figure that out doing the same process you just did. And then you would multiply this so it has 2 rows. So that splits up into 2s. So this is 4, 28, 42, 56, 2, -6, -1, 52. You would do the math. It would give you a new set of 8 numbers. Use the alphabet of 1 to 26 to calculate what the word is. If you need more help on this because you were absent, come to tutorials. I'll help you out. Or if you want to ask that first question before we start the test tomorrow, that's fine too. Yep. Anyone good? All righty.